All right, everyone. I'd like to introduce you to Gord. We've Cook. Gord's been given some previous presentations, some excellent ones on building construction, heat pumps, etc. And we've asked him to do one on green buildings, and it calls it Green Buildings Part 2. And I'll turn that over to you, Gord.
Thanks very much, John and Claude. Nice to see you. Thanks for having me. I'm sorry this is pre-recorded and we won't have a chance to ask questions, but you'll see there on my screen my email address. If you do have any questions on this, by all means, send me an email. I'll get back to you as quickly as I can.
Yeah,
As
or
John
they can
said,
reach out to Claude or I as well. So,
absolutely.
okay.
Thank you. And some of you were on this call before me, or on these sessions before. Remember, we did a little primer on some of the common energy efficiency programs, and then I talked about green building, and I thought I would just go a little farther, a little deeper. And in fact, I have a new initiative for you, something that we all need to be conscious of. So hopefully in the next 40 minutes or so, I can give you a little sense of where the industry's headed and how you might use some of the programs that are out there in your communities to basically to direct decision making. So let's get started. I'll do just a little bit of review of some of the common energy efficiency programs and tools that are out there. Then we'll talk specifically about green building programs and some of the objectives and some of the ones that are out there that I think are useful to look at. And then I do want to introduce, as I mentioned, this idea of low carbon housing, because that has become, I'm going to say, the new imperative, the new element that everybody's worried about, essentially on the climate change side. And then we'll finish up with just a little bit about some of the opportunities and challenges from the green building lessons that we've seen over the years. So hopefully that suits everybody's needs. And you may recall I showed this slide before, and if not, here's kind of the NASCAR slide of all the programs that are currently active in Canada. Top left is, I would say, federal government initiatives, the EnerGuide program. This program where you can rate a house on an EnerGuide scale, get an energy efficiency rating using a series of algorithms. This can happen, and it is happening in many communities across the country. This is part of the Greener Homes Canada program, but this label's been around since 2003. It gives a really nice base or background of how much energy am I using now. The metric that you see there, 144, that's 144 gigajoules, whatever a gigajoule is. It's basically a metric equivalent of kilowatt hours and millions of BTUs, say, of natural gas. But it's the base of how much energy you're using. And of course, the goal would be to get it as low as possible. The program to the bottom left, the Energy Star program, that's a US program, but it was brought to Canada in 2005. And it's a simple way, primarily almost, well, exclusively in new housing, to rate a house and to say, here is a house that is 20% better than code. That's where it's at. So it would take that a house at 144 top left, for example, and it would say, I want it to be 20% better than that. 20% of 144 would be roughly 30 gigajoules. So you would try to build a house that was in the 110 gigajoule range, and that would earn you the Energy Star label. Middle at the top, the R2000 program, some of the old timers like me on this call will recall the R2000 program developed in 1982. It's still there. It's still Canada's flagship program of energy efficiency, typically 40% better than new construction, standard new construction. And then in the middle, the new initiatives towards net zero houses, net zero energy houses that use only as much energy as they're able to produce themselves on site. On the right-hand side at the top, Passive House, which is the German program that's been brought back to Canada, if you will. The science really came out of the Canadian building experience. Germans took it and added some really nice enhancements to it. And now it's considered the most energy efficient of houses. And then some other items on the screen that we will chat about. The one in the bottom right-hand corner is the Quebec program, Nova Climat, and beside it to the left is the HERS program that is used in the US, but used a little bit in Canada as well. So those are energy programs. 3 of them on this screen, though, are what you would call green programs. So in addition to being energy efficient, the LEED for homes, LEED Canada for homes, the greenhouse program, and Built Green over on the right are programs that go beyond energy. And that's really what when we say green, that's really what we mean. They go beyond energy and look at other factors, and we'll talk about that. Only two of these are active right now in Canada. That would be the LEED for homes and Built Green on the right. The greenhouse program was an Ontario program. Right now, it's not an active program, but it's very similar to Built Green and LEED, so don't need to worry too much about that. In terms of I just wanted to use the passive house program as an example of kind of the extreme or the top end of energy efficiency, and just remind you, this is from session 1, remind you of what passive house kind of includes or looks like. And passive house uses a very sophisticated energy modeling software. It creates an energy budget for a house based on the square meters or square footage of the house. So the house is given an energy budget of no more than 15 kilowatt hours per meter squared of usable floor area. And I'm going to say to you, it's hard for you to know this, but that's a very rigorous standard. That's very difficult to do. And you also need to simulate if you're doing space cooling. And in northern communities, that may not be as prevalent, but in southern communities, you might be doing some cooling, and it too gives you an energy budget. And then it also gives a budget for the worst case heat loss. That is the size of the equipment. You're not allowed to put more than, say, 10 watts of heat per square meter of house. This is a really rigorous standard, is what I want to get across. The air tightness levels, very rigorous air tightness levels. For example, the R2000 program, which is kind of Canada's tightest of houses, 1.5 air changes, and this is less than half of that. And then there's a very comprehensive design process and review, comprehensive quality control. It's an excellent program, has tremendous rigor to it, but it is very stringent, and you'll see why in just a second. And then there's a certificate issued. Fairly extensive consulting fees to get this done, but clearly the most efficient of houses in terms of a program that we could imagine. What we do need to know is the passive house program was designed essentially for Europe, for Germany. And if we look at where Germany and most of Europe falls on in terms of where our climate is, it really is kind of the coastal regions of Vancouver. That is the climate that we would associate with Europe, is kind of the climate of the coastal regions of British Columbia. So when we say there's an energy budget of 15 kilowatt hours per meter squared, that's pretty easy to achieve in, say, Vancouver, Lower Mainland, but it's not so easy to achieve in, say, Northern Ontario or in the territories. So not that it's a bad program at all. It's just that it's a very rigorous standard, and you have to meet that same requirement wherever you're building in the country. So that's pretty interesting. And as an example, in terms of insulation levels, a typical passive house, say in Ontario, central Ontario, for example, you'd have R100 ceilings, you would have R45 to R75 in the walls, 35 to 45 in the basements, R25, that's 5-6 inches of foam underneath slabs, triple glazed windows, which is where, of course, we should all be, but it may be even quad pane windows in northern climates, and then that airtightness. And what most communities find is that's very expensive to build. Excellent in terms of long-term operation, but very expensive to build out to shoot. Typically, on a typical community house, say 1,200 square feet, something like that. This house here you see is 1,250 square feet with a little attic up above it at 600 square feet, a little attic space. The incremental cost to go to passive house here in terms of insulation levels would have been the order of an extra $20,000 to $30,000 in terms of insulation. So an excellent program, but the enclosure requirements are pretty extensive. So that's passive house. And similarly in the mechanical room, we're always looking for heat pumps, which we're going to be at heat pumps anyway, but also heat pump water heaters and very high efficiency HRVs and ERVs, LED lights and Energy Star appliances, nothing wrong with that. And ultimately solar ready, but the cost there is typically in the in the mechanical side, $10,000 to $15,000. So I don't want to sound negative about passive house. I would just say if you're going down that path, you're in for very efficient housing, but at an incremental cost that uh, may be outside the budget, if you will. But I really like the idea of passive house of setting a budget of amount of energy per square meter, per square foot, whatever you're in. It's kind of an interesting concept, isn't it? To say, regardless of the house we build in our community, they're going to use no more than this amount of energy per square meter. That's what our codes are moving towards anyway. The number you choose, whether it's 15 or 20 or 30, that's a different story. But it's kind of an interesting concept of setting an energy budget. And then I want to move, that was just sort of a review of programs, but I wanted to move towards green building programs. And I've mentioned two, Lead for Homes and Built Green. And I've added a third, which is, again, a European program, but it has come to Canada, called Active House. And I think it has some interesting elements that I think is kind of a useful concept. So I thought I'd mention that. All these green building programs include energy efficiency measures. In fact, most of them use the same metrics that we saw in R2000, Energy Star, and so on. So when you're doing a green house under the LEED program, you're still doing effectively the same thing you would do in an Energy Star house or an R2000 house. You would use the software there at the bottom right, a software called Hot 2000. Pretty simple, well, I shouldn't say simple software, available software is maybe the way I could put it. There's training courses available as to how to use it. Basically, you're building the house on the screen. It's a simulation program. You're entering square footages and installation values. It's actually a free software. If you Googled it, it's something you can play around with and basically put in the square footages of your house, the wall areas, the floor areas, and so on. And it'll spit out an energy use, and those are that's software that's used for all of these programs. But then they have additional requirements for things like indoor air quality, things like durability, material conservation, and water conservation. In fact, I can go just a little deeper on that. I love the little picture on the right. That's from years ago. Somebody had done this little joke about what is a greenhouse? Is it all are we talking about green roofs and so on? No, that's sort of a little goofy, but I would say all green programs identify and reward initiatives in 4 specific areas: efficient use of land and water. Water is interesting. Efficient use of energy, which we already covered. Then efficient use of construction materials, and then healthy indoor environments. And I don't think anybody could argue with any of those, right? Let's make sure we're energy efficient. Let's not use more water than we need to. Let's not waste construction materials. But for the most part, for all, I would say, really want to think about healthy indoor environments. So in all of these green programs, typically you're working with consultants to attain and certify credits in each of these areas. So at first blush, pretty straightforward. Then the devil's in the details, I guess. And the most comprehensive, if I was to say the one that has the most resources, the longest life to it, it would be Leadership in Energy and Environmental Design. It was specifically designed in the 90s for the institutional commercial sector, the ICI sector, so public buildings. And I suspect in some of your communities that you may have, for say, community centers or offices, you may in fact already have LEED certified buildings, because it is a very comprehensive program designed, as I say, specifically for those kinds of buildings. But in 2009, so it's 13 years ago or so, they developed the program specifically for houses, and it is a very comprehensive program. You'll notice there a review process, in this case in 8 categories. I'll show them to you in a minute, but the same elements: water, energy, indoor air quality, waste, transportation, and so on. And in the case of LEED, it's all done based on credit points. And depending on how many credit points you're able to accumulate, that gets you different levels or rewards: certified, silver, gold, platinum. And when I say rewards, these are rewards in the form of a plaque. There's no incentives available that I'm aware of. There may be in certain areas, but it's run by the Canadian Green Building Council. Great program. And one of the most important parts about this program is they have these great guidebooks. They go through each one of these points and each one of these programs. And if you were looking to make a decision, for example, when you say water conservation and you want to know what that means, the lead guidebook would give you a really good sense. You would look up the water conservation and it'll tell you, what to look for, where you might find materials, how to rate those materials. So it's a very useful program just from the resources it provides if you're trying to make decisions in your community, whether it's in new or renovation projects. How would I know if this is a water conservation product? We'll look it up in the lead guidebook and you'll find it. In terms of, just I'll give you a sense of, there are the 8 categories in LEED, and you go, wow, that's pretty interesting. So you get points for innovation, you get points oddly, maybe not oddly, but you get points up to 10 points. Remember I said 136 points just for locations and linkages. For example, my little cottage that I showed earlier, that little yellow brick, I can walk to a school, I can walk to a hospital, I can walk to the community center. So I get all 10 points for not having to use transportation, vehicles, and so on. That's, you would say, is that applicable in our communities? Well, perhaps because of the nature of your communities. Some of you would say, no, we have to drive everywhere, the nature of the community. So this is an interesting one. You may not get many points on there, but you also get points up to 22 points for sustainable sites. And when we say sustainable sites, it's things like maintaining trees, things like zero landscaping, so it doesn't need irrigation, those kinds of elements. You'll notice the biggest number of points are for energy efficiency, 38 points. So that's that HOT 2000 modeling. You, interesting enough, get as many as 10 points for awareness and education, just by, for example, in the community offering education classes while the house is being built. You could get awareness points. Oh, sorry, that's 3 points. My apologies. That 10 points is left over. 3 points for awareness. You get 21 points for indoor air quality. That's an interesting one, right? That you get a really good emphasis for making sure that the air quality inside a house is equal. What does that mean? Well, it's about deciding on ventilation, for example, filtration. You get points for things like low off-gassing materials. Materials that don't give off gases would get you points under the indoor environmental quality. You get 16 points for materials and resources. So what's that? Recycled materials, locally made materials. If you had a local sawmill, for example, you would get points for that. It's 15 points for water efficiency, and then just 10 points for innovation and design. So out of these, you try to accumulate as many points as possible, and that heads you towards this rating. And I'll say again, whether you ever go through this, because it's pretty extensive, whether you ever do this or not, that's not the point. The point out of this is it offers great resources to you. Download the guidebooks if you're trying to make decisions as a community as to what would be good materials, what would be good water use, what would be good air quality. There's some really good descriptive points on this that point you towards, I would say, greener buildings. So it's very useful from that perspective. And then I want to mention, I mentioned this new program, relatively new program to Canada called Active House. And this was a reaction, frankly, to Passive House. Passive House was very clearly all about energy efficiency. And these folks said, there's more than energy efficiency. We want to balance energy efficiency against comfort and against the environment. And their concept here is you build a radar and you're given points in each one of these categories. So you see under comfort, you're given points for daylight there at the top. You're given points for better thermal environment. On the energy side, you are, of course, given points similarly to passive for energy demand, energy supply, your primary energy performance. But there on the environment side, notice fresh water consumption, environmental loads, sustainable construction. And in this case, you have up to 5 points available to you. Scales 1, 2, 3, and 4. And when the goal here is to make the radar look balanced. This is a pretty one you see on the screen. This was a house built in Southern Ontario. And it was a house that achieved a good balance. It had some nice energy efficiency features. That's what filled out the radar to the right-hand side. But it had some really nice sustainable construction features in terms of reclaimed materials and so on. That gave it some really nice points on the environment side. And a lot of work was done on the comfort side to make sure the house was very comfortable. So the ideal goal would be that this radar would look filled out and round and not too skewed. So it's kind of an interesting concept of keeping in mind that we need to achieve a balance, that we don't want to just do energy efficiency. We want it to all work together. Hopefully you find that kind of interesting. Active house ultimately works you towards using the active capture of sun and wind and ground heat. So in the biggest of points from an energy and from the environment standpoint is to be self-sufficient. And you can start to imagine that in some of your communities of saying, could we make each individual house independent, off-grid, if you will, not necessarily off-grid, but less reliant, say, on the public grid. It would be kind of an interesting concept, and active house moves you towards that is what we'd like to say. And then just as we move on, so that's green overall, I want to move us to the next one, which is reducing carbon, which is that new important goal we know from a climate change perspective. As a country, we've committed to 40 to 50% reduction of carbon. And when we talk carbon, we need to talk about two things. On the right-hand side, down at the bottom, you'll see operational carbon. That's the amount of energy that we use to heat and cool and lights and appliances. That is the energy we use. That's operational carbon. And you think about electricity and natural gas and oil, fuel oils, and so on. Those are all operational carbon elements. On the left-hand side is the upfront or embodied carbon. That is how much carbon was released during the manufacture of materials, during the transportation of materials. And this new and latest gig is to understand this new trend is to say we want to find a balance between these two. Passive house, for example, wants huge amounts of insulation. That's great from an operational standpoint, but what does it do on the upfront carbon? Making that insulation, for example, what's the operational? And we have this imperative that says between now and 2050, we need to reduce. So we still need to build houses. We need to remodel houses. So there's always going to be some embodied carbon as we make materials. Can't stop building. But could we build with materials that have lower carbon emissions during the manufacture? So I'll probably run through some slides that are perhaps more complicated than you really need for an introductory session. But I would just encourage you to watch this initiative, see where things are headed. And again, you're going to find it's going to help you make decisions in your community with respect to construction materials, construction methods, if you will. And so the idea here is thinking about the total building life cycle from on the left-hand side, from the raw materials, the manufacturing, then the construction, the maintenance, the repair, then the operational side, and ultimately the end of life, what happens to a building at the end of its life. Now, typically houses are lasting for generations, so we would say we're not as worried about end of life in houses, but what about end of life in, say, materials that are in our communities that are perhaps changed more often? For example, windows. Let's choose windows that will last longer. Let's choose cladding systems that will last longer so that we don't have to worry about those end-of-life disposals. So this is the idea of total carbon counting. And we start with operational carbon. I'll just do a couple of slides on that. And it's really about the amount of energy. So we're right back to energy simulations using the same HOT 2000 energy simulation tools. And we look at the total annual energy consumption. And you will have an understanding, appreciation that, lights and appliances, and if there's air conditioning, those are run off electricity. In the heating and hot water, that varies by community, right? Some communities would be using natural gas. Some would still be on fuel oil. Some would be on electricity. So the operational carbon is simply how much energy you use, but then it also is based on the fuel that you use. So for example, in Ontario, our electrical grid is primarily hydroelectricity, water over the dam, and it's nuclear energy. We have some solar, we have some natural gas, but our grid in Ontario is relatively clean. So when you use electricity, you're using a very clean, from a carbon perspective, energy source. Other parts of the country, Alberta, for example, much of their electricity is from the burning of coal, produced from the burning of coal. Well, that has much higher carbon emissions associated to it. Doesn't mean it's bad. It just means you'd want to use less and less energy in Alberta than you would, say, in Ontario. And this again helps make decisions. That if I'm in Alberta and I want to reduce carbon, I want to put more insulation. I want to use less energy because that energy is coming from a source that's carbon based, that's coal and natural gas and so on. So it adds a level of complexity to the conversation, but it's still fundamentally it's about energy use, operational carbon. So here's what happens. They do an energy simulation on a house there on the right-hand side. This particular house in this location used 81, let's say 82 million BTUs. That's what stands for, millions of BTUs of energy. It uses 26 millions of BTUs in electricity for a total of 108. Now I would need to look at where that house is built. If it was built in Ontario versus Alberta, then I would have different contributions. The gas is pretty much the same carbon contribution across the country, but electricity varies dramatically. That is, there in a house, electricity in Calgary, there's about 3 to 4 times more carbon emissions from electricity in Calgary than there is, say, in Southern Ontario. So just keep that in mind, that it's partly about the grid that we use. So for example, this particular house, the natural gas was 53 kilograms of carbon dioxide, CO2, for every million BTUs that's generated. Electricity is 449 kilograms per megawatt. And I'm throwing a lot of acronyms at you. Don't worry about it too much. But the point is, our operational carbon for this house is 7.82 tons of carbon dioxide carbon dioxide equivalents. We take all of the global warming potential of the gases that are emitted during operation of this house, and it comes out to 7.82. And you would say, is that a lot? Is that a little? That's fairly high. A typical house in Ontario, because of the electricity use, is quite a bit lower than that. It's more like 4 to 6 tons. This happens to be in an area where it's a lot of carbon used for generating electricity, a lot of carbon emitted. But this is the new idea. And of course, this is your first introduction to it. So at the moment, you don't really know where this fits. And that's where I was at literally 3 months ago. This is so new that even 3 months ago, I didn't have a full appreciation for this. But we now start to learn that, okay, I need to worry about operational carbon. And of course, to reduce operational carbon, I can start to think about things like more insulation on walls at the top left, more insulation in basements, bottom left, the air tightness, the triple glazed windows, and then mechanical systems. And then ultimately I could put solar panels in a house, and now that's totally green power. So if I'm running my house off electricity and the electrical grid is coal fired, you would say, well, then let's put solar panels on the roof because that's a much cleaner source of electricity. So this is the kinds of decisions that you start making with operational carbon. And here's a little example. Oh, I'm showing Chicago here, my apologies, but think cold climate on the left there. But think about taking house in terms of air tightness, which a typical new house is 3 air changes, and take it down to R2000 levels, which is 1.5 air changes. And you'll notice that's a 7.82 to 7.44. That's a 5% reduction in greenhouse gases per year. So if I make my house tighter, I've reduced my carbon footprint by 5%. And you ask, well, how much carbon was released while we did that air tightness? I used some caulking, some foam, some tapes. Frankly, we didn't use a lot of carbon to get that level of air tightness, and yet we got a nice 5% reduction. Kind of a neat idea. And then you'd say, what if I put insulation on the outside of the house? For example, R5, 1 inch of foam or 2 inches of foam. And if I put 2 inches of foam on the outside of the house, again, I would show a 5% reduction. But you can probably imagine the amount of carbon it would take to make that insulation is higher than what it would take to make a house airtight. Because making a house airtight is just some simple foams and caulks and tapes, whereas this is hundreds of square feet of insulation 2 inches thick. So I'm not saying it's a bad product, but you would have to say, I'd probably first, from a carbon perspective, first make my house airtight. Second, put insulation on the outside in terms of carbon. And be aware, be aware, just that that's insulation choices. And then understand that when we do carbon, we're going to get towards heat pumps. Why? Because heat pumps are about 300% efficient. So in your communities, more and more, especially in communities where you only have, I'll say, expensive fuels, propane and so on, which also give off carbon emissions, we're going to be moving more and more towards heat pump technology. And you'll say, well, but it's using electricity. And didn't you say electricity was kind of dirty depending on where it's generated? Well, it is entirely dependent on where it's generated from. But in general, heat pumps, because they're so efficient, for every dollar of energy you buy, you get $3 to $4 worth of heat. There is going to be a move towards heat pumps. And in your communities, that can be a challenge, right? Because now I need refrigeration technology. I need servicing of that equipment. So we're going to have to look for and train community members who are able to maintain, service, install, maintain, and service heat pump type products. The good news is there are all kinds of new heat pump technologies available to us, mini splits, so on, that work in really cold climates. And some of you would be in really cold climates. And now we have heat pumps that actually do work in those very cold climates. The next, and I'll do this fairly quickly, is to talk about embodied carbon. That is the carbon that's involved in the extraction of the raw materials, the transportation of the factory, the production of what's referred to as cradle to gate, the gate of the manufacturing facility. So let's use that insulation as an example. It's an oil-based product, a foam insulation, oil-based product. So I had to extract that from the oil. I had to make the polystyrene. Then I had to manufacture the foam. Then I had to ship the foam, so on and so on. That's what we think about when we think about embodied carbon. And it is taking into account on the left-hand side there, down at the bottom, the cradle to gate. We don't include in this one the construction and so on, or the operations. We've already done the operational side. It's what's happening with that product while it's being manufactured. And here is an example of that insulation. The amount of insulation, and this is emitting on the right-hand side, 6.9, let's say 7 kilograms of carbon per meter squared of material. Now, Owens Corning is just reduced. This is showing the reduced number. Owens Corning, because of this carbon initiative, they just reconfigured their extruded polystyrene and reduced the carbon footprint by 90%. Can you imagine? They reduced the carbon footprint. They just changed the way it was manufactured, as did DuPont. All the foam manufacturers have just reduced the carbon footprint. Still has a carbon footprint, 7 kilograms per meter squared. Again, we don't know exactly where that fits in. I'll show you that in a second. But they all declare, and the interesting part is all leading manufacturers now declare what's called an environmental product declaration, an EPD. This too, for those of you in the construction side of this, building houses, at some point you're going to say, I need to ask my suppliers for their EPD. I need to know how much carbon they're giving off. And then what happens is there's another simulation tool, much like HOT 2000. This is the tool that most are using. It's called the BEAM tool. It's called the Building Emissions Accounting for Materials. And it's free. It's fairly simple to use. And it has a whole bunch of building materials already in it. And you do basically the same thing that you did with energy. You decide what's included in the model, and the model includes structure and finishes. It doesn't include things like furniture and fixtures. It doesn't even include mechanical systems, but it looks at the enclosure on the left-hand side and says, how much carbon is used or emitted as I build the house with the various materials. And it's very similar to any other energy simulation. You enter the house, square footages, areas, so on and so on, and then you pick the materials you're going to use, and it determines the amount of carbon that that house gives off. And as an example, this house, you saw the house there on the left-hand side, little two-story house. there is the materials from highest carbon. And you'll notice this house had brick, and brick has a lot of carbon associated to it because of the way it's made. Concrete is very high carbon content. And you go, what do I do? I need concrete to pour my foundation. Sure. But is there concrete that has less carbon impact? And yes, there is. There's now concrete where you put additives to the concrete that reduces the amount of cement that's needed, and it dramatically reduces by 30 or 40% the amount of carbon emissions. Notice the floors, the windows. Windows are 3,000 kilograms of CO2. So again, this is done in the background. It just helps you make good decisions. If you look at exterior cladding, you would say, well, could I build with something other than brick? Well, sure. I could use wood siding. And wood siding products have really low carbon input because they are storing carbon for us. The trees are storing carbon. So in terms of where the changes we want to make, you'll notice here concrete, brick, and insulation represent the biggest categories. So we need to think about what materials we're going to use and try to reduce carbon in those buildings. And then you would calculate the total carbon emissions. And I just want to make a point here. On the left-hand side, the embodied carbon doesn't really matter where you're building the house. Concrete, so on, all have roughly the same carbon input in Calgary as they do in Ontario. The operational carbon is very specific to the geographic region you're in. So the embodied carbon, you can do a calculation just about anywhere. The operational carbon, you immediately need to know, where do I live? What's my electrical grid look like? But the idea here is to add the two up, to look at the embodied carbon, say, in the first year, and then look for the 30 years of operational carbon. That we use typically 30 years because by 2050, we're supposed to reduce by 50%. So we look at the 30-year implication of carbon. And you'll notice here on this list, on the right-hand side, the embodied carbon was 79 tons. My apologies. The embodied carbon is 72 tons. The operational carbon is 7.8 tons. So in the first year, that's 79 tons. The operational carbon over a 30-year period, look in the middle there. I don't know if you can see it, but there you have it. Look at the middle there, that over 30 years, the operational carbon is clearly much higher than the embodied carbon. That's what I wanted to get to. That the embodied carbon is a constant. It doesn't change over the years. The operational carbon, each year, we're using energy each year. So the idea here is, what's the sweet spot? Where's the spot at which we'd say, I want to put in more insulation, but I don't want, and so I want to reduce the operational carbon, but I don't want to increase too much the embodied carbon. So you're playing a bit of a game here to find the balance point of where we head with this conversation. And generally speaking, over a 30-year period, the operational carbon, again, I'm showing a Chicago house. We did this for a US builder. We showed that the operational carbon is much bigger than the embodied carbon. So we would say, put more insulation in your house. Put more insulation in your house. Even though it increases the embodied carbon over a 30-year period, it'll balance out and reduce the operational carbon. So it depends, of course, on where you are. If you have a very clean grid there on the right-hand side, you might be 50-50, and you might say, I don't need to add any more insulation because I have a very clean grid. Or are you on the left-hand side that says in your community? And if you're using fuel oil or diesel to generate electricity, then you would say, I definitely want to add more insulation in our community. So it's very much about where your electricity is coming from in your communities as to where you'd want to spend time and effort on insulation. And then, of course, you would, once you've done the initial model, then you look to design materials, design the house, and look for materials to reduce those opportunities. And in terms of, I won't do that one, what I would say to you is, wood is always good. If you're building out of wood and using wood products, wood almost gets a free pass in the carbon world. Why? Because it's absorbing carbon during its life cycle. once you cut the tree down and use it in construction, you're now sequestering that carbon. You're hanging on to that carbon. It's been captured. And of course, as long as you're planting trees, now you are absorbing more carbon out of the atmosphere. So wood is seen as a positive thing. To harvest wood in a sustainable way in your communities is considered a very good carbon decision because it's sequestering that carbon and allowing new trees to grow that absorb even more carbon. So pretty useful. And I just wanted to show you one example. I'll skip over the rest. But if I made went from say, I'll do this one, the air tightness. Remember I said I reduced the embodied carbon by 5%. Well, and I have really no operational carbon by 5%, sorry. And we really have no embodied carbon associated with this. So that means from a carbon perspective, by doing air tightness, it's about a 1-year return on investment of carbon. The best carbon decision you could make in your communities would be to make your houses more airtight. Another good example is windows. From going from double glazed windows to triple glazed windows has about a 2-year return down at the bottom there, 2-year return on carbon. It's a very good decision to make because it doesn't add a lot of embodied carbon, not a lot of extra carbons needed to make that third pane of glass, but it has really nice operational savings. So those are the kinds of choices that you would make. I won't do that one. And then here's a house that actually has a low or negative carbon. That is, when we go to concrete with these what are called supplemental materials, 35% supplemental materials, and if we used treated wood foundations or hempcrete, if we used walls with straw bale insulation, if we use straw attic insulation, so on and so on, we can actually build a house. Notice down at the bottom here, it has net reduction in carbon. That's a house that actually absorbs carbon, sequesters carbon. So, I mean, it might be a little bit out there to say I'm going to use straw bale, but we can, in fact, and over time, build houses that will sequester carbon. Kind of an interesting concept, hopefully, that you'd understand. So let me finish up by saying this. When we think about green programs, energy efficiency programs, I would say to you in your communities, don't chase green points. Don't chase labels. Don't chase gold, silver, platinum. That's really that's these green programs, that's not really what they're about. What they're really about for your communities is to make good decisions. Use the resources available from those green programs, from their guides, for example, to help make decisions because they help identify better materials. Who knew that I could build a negative carbon house if I just picked the right insulation materials, a cellulose insulation, for example, rather than fiberglass insulation. So use these programs to help identify better materials. They also help evaluate the relative value of different options. We saw that triple glazed windows and air tightness from a carbon perspective have lower carbon emission in terms of embodied carbon than, say, foam insulation. Not that you're not going to put insulation on the wall, but do the air tightness first, do the windows first, for example. And all of these programs provide really good opportunities for training. All of these programs now are offering training online or in person, and it's because it's all synergistic and they're all using the same energy. You'll find some of your community members, some of your housing authority folks on this call would say, that's training I should take. And whether I actually use that program or try to get that label, this helps me learn more about how houses are built and better choices in houses. And one of the key elements that comes out of all these programs is try to use local resources, materials, methods, and skills. That on a green scale, that gets you a lot of points. It gets you points in material conservation, gets you points in sustainability. So always the focus should be on trying to use local resources as much as possible. And the final statement is this: you're trying to find a balance between what's practical and cost effective and sustainable. It's not about achieving Passivhaus label or greenhouse label or LEED label. It's about finding a balance that works for your community, that what's practical in our area, what's cost effective based on our locale, based on our energy grid, and ultimately what's sustainable. Forestry is a good example of that. So that's, I would say, the lessons out of green. Don't chase green, build a good house, use the resources. And if your project happens to qualify for a green label, by all means, go ahead and get that to recognize, gives you a little sense of pride of what you've been able to achieve. But most importantly, use the resources available out of those green programs. Hopefully that was helpful. John, Claude, any comments, questions?
I have a lot. It's, geez, it's incredible, Gort. It's information overload, notwithstanding. I remember most of these slides from last time, and that was information overload. So, but I have a couple
Well, I will
questions.
say this. I will say this. It is layered learning, right? It's layered learning. You got to hear it more than once. And encourage everybody
Oh,
to watch and rewatch. Yes.
yeah, no, I totally agree with that. So I guess the challenge for a lot of First Nations, and you focused on it a little bit, was cost, right? And we know the more the remote, the more those costs because of transportation. And I guess the challenge that a lot of communities face is trying to understand or balance the long-term costing. So if you build, so right now it's always the bottom line, right? I got a house I'm going to build for 250, and that's what we're building. But how do we change the thinking to say, yeah, but if you borrow, because housing is not free for First Nations, they have to borrow money. But let's say if they borrow, another $50,000, the long-term savings is here. And how do we do that type of modeling for First Nations? Or is that possible? Do you say if
Oh,
you did it? So,
sorry, it's absolutely possible. I will say it's absolutely possible. That's the beauty of, I would say, of the energy programs, green and energy programs. They're all based on well-developed software. And the software is not perfect, like Hot 2000. It's not perfect, but it's very close. I could give you an example. My own house, I built in 1992. I did an energy model on the house. I track it. I'm always within 5% of the energy that they said I was going to use. I'm always within 5% each year. Some years it's a little more, some years it's a little
oh,
less, depending on how many kids are living in the house at the time, how cold it is. But in general, I use that amount of energy. So we can use the energy programs and the software tools available to us to say, how much energy am I going to use? And then it's fairly straightforward to then say, and how much does that energy cost? And for example, in remote communities that are using very expensive fuels, you would say, whoa, I definitely want to add more insulation in those houses because the payback is going to be that much quicker. So I would say it's one of the most important lessons out of these slides is to say, by all means, get an energy model done. And that energy model can be done remotely. That's not that expensive. A typical energy model on a house is $300-400. And in general, you could say, I'm going to do what we do for builders in the mainstream community is we say, here, give us your most common house that you build, and we model it. And when we model it, we use that as a surrogate for all other houses. So I don't necessarily need to model every last house. I want, in order to make good decisions. And as you saw from the slides, one of the things you learn really quickly is things like air tightness are more important than, say, more insulation in the attic. So the energy models and the green programs start to help the communities prioritize, what do I do first? What do I do second? I mentioned, for example, you're going to end up with heat pumps in your houses, but don't do heat pumps first. First, reduce the heat loss and heat gain of a house by adding, making it more airtight, triple glazed windows, and so on. Now, the interesting part is the heat pump that I need for that house is much smaller because I've reduced the amount of energy that I'm using. Instead of needing a 4-ton heat pump, now I only need a 1.5 or 2-ton heat pump. That's the beauty of these programs is that, and it's accessible. I'm going to say very accessible to all communities to do some energy modeling on their houses to start by helping making decisions rather than saying, a manufacturer says, here, put this in your house, it's great. No, let's model it first. Let's see what the impact is and decide based on our community, our grid, our energy sources, whether this is going to be cost effective or not.
yeah. And I believe that through our Indigenous Building Knowledge Exchange, we have monies for communities to approach us that we in fact then could hire somebody like yourself to do those models. So we have money available to do that. So if communities want to reach out, contact Claude and myself, and we can make those arrangements. So my second question is training. Who would provide the specific training? Like, would they go to like the leads, or would they go to one of those NASCAR labeling? I like that. And which training would you suggest they take? Because that's always really important. So, for example, Ian's group, the ICE, the Indigenous Energy, what are they called?
Clean energy?
Yeah, Ian's group, who just gave a presentation. I know that they're trying to offer some type of training as well, right? And certification.
Yeah, so I would start with the training that comes from um, uh, that's based on the EnerGuide program, because the EnerGuide program in Canada is kind of the base of all the other programs in terms of energy modeling. And there's a group, there's service providers will provide training at a cost. Typically for remote communities, I would have them start with, there's a little group called Blue House, and write it down, folks, Blue House Energy. They have online training. It starts from very basic building science training, just air, heat, moisture flow. It's online. There's little exams along the way. It is at a fee for service basis, but it's in modules. It can be done on your own time, and it forms a really good basis. Perhaps before you started traveling to get training, you would say, hey, that's first layer. Because as I said earlier, it's layered learning. I've been doing this a long time and I'm still learning stuff. So I would say, think about 3 different opportunities. First, basic level, and then perhaps a second level. Second level, you might go to an individual program. So, for example, the the Canadian Green Building Council offers lead training periodically for lead raters and lead associates. So you could take that training. It's a 3 or 4 day course. Passive House offers a 3 or 4 day training program. There's energy advisor courses. That is, if you want to become an energy advisor, which is great training. Even if you don't want to become an energy advisor, you could take that training because it gives you that second level. The third level of training, I would say, is more experiential. You might need to travel for that, or perhaps bring somebody up to the community and say, we actually want to do a build. Let's go. We have something under construction. Could we use that house as an example? So think about it as not just individual training, but 3 layers of training to get you ever deeper. That basic building science, air, heat, moisture flow, and then maybe application in terms of a particular program. And then lastly, something at an experienced level. So that is available. And I know FNNBOA and others, obviously you guys are doing training all the time as well. That's where I would head people towards.
Yeah, it's the Indigenous Clean Energy group also are trying to provide various types of training as well, right?
Wonderful.
Yeah. Okay, Claude, any questions?
Maybe just a few quick comments. Certainly a very informative session. Gord, I was going to talk about, or maybe question the issue of how about grants? Are you familiar with some of the grants, or we'll call it money saving initiatives that possibly are out there?
Yeah, certainly the big one right now is the Canada Greener Homes program. Very specifically, it's geared towards getting off of fossil fuels. So incentives for heat pumps, for example, incentives for insulation, incentive for solar panels. So that's Canada Greener Homes, and there's $5,000 in grant, and then there's low interest loans. In addition to that, there are now utilities. I'm out here in BC right now. Fortis Gas BC, they have incentives towards energy efficiency in both new and existing houses. So if you're serviced by Fortis, either the electric side of Fortis or the gas side of Fortis, so there's incentives. Enbridge Gas in Ontario still has incentives available if you're in gas communities. It is on the electrical side, if you're an all electric community I'm not aware of any right now, other than there is dollars available, or at least there's some grant monies, proposals out there, and John, you know more about them than I do, that
Yeah.
on a community scale, looking for opportunities to reduce greenhouse gases. I would say right now it's all about greenhouse gases, carbon, but the federal government is looking for innovations or innovative opportunities, innovative opportunities to reduce on a community scale. But on a per house level, right now it's pretty much the Canada Greener Homes program that is offering the, I would say, the cleanest of the incentives, even though they have to have an energy audit done and so on and so on. But there's at least a process in place to make that happen at roughly $5,000 a house.
Yeah, there's the move now is net zero, right?
Yes, ultimately net zero is where you like to get to, but again, there are no incentives specifically for that term or that label.
Yeah. And that's and that seems to be the new terminology right now. I know when we were doing our technical guides for Northern Housing, like we focused on energy efficiency and insulation and windows, but we didn't even use the word like net zero. And that's just like a few years ago, right? And so,
It is interesting, isn't it?
oh,
It is a relatively new term that's going very quickly and very attainable. I got to say, in your communities, net zero is not unattainable. It's not huge amounts of insulation. It's I think it's quite responsible, and we can show it to be very cost effective in most communities.
yeah, and exciting. It's really, really exciting. And I think there's a lot of opportunities. Again, we, FNNBOA, put a proposal in to do some work. And I know that the Indigenous Clean Energy has proposals, and a number of other communities have proposals on net energy. So it's quite interesting. But it's moving really fast, and there's substantial funds for it as well, right? So
Right.
yeah.
And so if I could just finish up, I'll just remind
Yeah.
folks, and as you said, there's always these presentations, there's probably more information than we should try to put in, but I just want you to remember two things. Green building programs, whether you use actually get a label or not, provide excellent resources. Just go ahead and download and search them out. Excellent resources, either for training or just, help you make decisions. And then, as you kind of mentioned, John, the most important part is to find a balance of what's practical for individual communities. And I'll be very clear, what's right in one community that's, say, on propane far north is going to be different. That's a community that has natural gas servicing it in a warmer climate area. And it's okay to understand that different solutions are going to be needed for different communities, and always looking for that balance between the practical, cost effective, and sustainable at your community level. And the resources are available to you through training and so on, through NRCan, through organizations, companies such as yourself. As you say, energy modeling is available to everybody at a very reasonable rate.
Right.
So thanks very much for the
Thanks,
opportunity. It
Gord.
was, as always.
Thank you, everyone.
Thank you.
Thank you.